Okay, class, now let's look at the patterns in our special angles that lie in quadrants 3 and quadrant 4 on the unit circle. Okay, so let's say that I, again, start at theta equals 0 radians, and I rotate counterclockwise, okay, all the way here to pi radians, but then I continue until I hit that little line segment there. Okay, so what is the measure of that blue angle? Well, I see that already I've passed pi radians. So of course this has a measure greater than pi, but now I see that this blue angle has a reference angle, which is that little red angle. But that little red angle is the same as this angle here in quadrant 1, which was pi over 6. So that means that if I want that measure, I'm going to take the measure of the half circle, which is pi, but now I'm going to add the reference angle, which is pi over 6. Okay, so if I want to add, I have to find a common denominator. That has a denominator of 1, so I multiply top and bottom by 6. Now the denominators are the same, so we add the numerators. 6 pi plus 1 pi gives us 7 pi over 6. Okay, so this blue angle has a measure of 7 pi over 6. Let me move this somewhere else. Okay, so I'll write quadrant 3 over here. So again, that angle in blue has a reference angle of pi over 6. The numerator is 1 greater than that denominator. Okay? Now, what is the next special angle? Well, I'm going to now rotate into quadrant 3. But now notice that that green angle has a measure of what? Well, it's going to certainly be pi, but then added with the reference angle. But the reference angle would now be this here. Okay? But that little angle in red is the same as what? Pi over 4. Okay? So, if you want this measure of the green angle, you're now going to take pi and add that with the reference angle, which was pi over 4. Okay, so here, let me write that in red. The pi over 4 is the reference angle. Okay, but again, if you're going to add them, you're going to find a common denominator. So 4 pi plus 1 pi gives us 5 pi over 4. Okay, so this special angle is 5 pi over 4. Okay, and so I think you can already see what the pattern is that in quadrant 3, these special angles have numerators which are 1 greater than the denominator. Okay, so the next one, okay, let's do this purple angle here. It would be what? All the way, here's pi, but then if I continue down until I hit this line segment, okay, then now your reference angle is going to be what? Pi over 3. That angle in red is the same as this here, pi over 3. So, that angle in blue has a reference angle of pi over 3, okay? But it's going to have a numerator that is 1 greater than the denominator, okay? So again, if you want to convince yourself even further, you would take what? The half circle, which is pi, and then add that with the reference angle, which is pi over 3. And you will get 4 pi over 3. Okay? So, comparing to what we saw earlier, that the special angles in quadrant 2 have a numerator that is 1 less than the denominator. And in quadrant 3 now, the special angles have numerators that are 1 greater than the denominator. Okay? Now, Now, I want to look at the special angles in quadrant 4. So if I were to rotate here, let's say from 0 radians, now I rotate all the way until I hit this angle there. Okay. I see that this angle here in blue, which is in quadrant 4, it has a reference angle, which is this red angle here. Okay, so now what is this what is this angle here in blue? Well, what we can now do is take a full 2 pi, because we know that a full revolution here, the circle has a measure of 2 pi radians, but now you're going to subtract the reference angle, but this reference angle is the same as this one here, which is pi over 3. Okay? And so now, finding a common denominator, I would have to multiply this fraction top and bottom by 3. And so now that would give me what? 6 pi over 3 minus pi over 3, and that would then give me 5 pi over 3. Okay? So this special angle right here has a measure of 5 pi over 3 radians. Okay? So notice, what did we do? How did we get that 5? We really had to take the denominator, which was 3, and we had to double it. Okay? It got doubled because it was multiplied by the 2, producing a 6. And then we had to subtract 1 to get 5. Okay? So if you think about that, that numerator is 1 less than twice that denominator. Okay? And so that's going to be the pattern for your angles in quadrant 4. Okay? So this angle here, so let's say that, here, let me extend here. From 0, I'm going to rotate all the way into quadrant 4, and I'm going to hit that line segment. Okay, but that green angle now has a reference angle, which is this angle here in red. And so what is its measure going to be? Well, it has a reference angle of what? Pi over 4. Okay. And now all you're going to do is double the denominator. So 4 times 2 is 8 minus 1, which is going to give us a numerator of 7. Okay. And then lastly, this angle here has a reference angle of pi over 6. But now I'm going to double that denominator to get 12, and then 12 minus 1 is going to give me 11. Okay? So that would be this angle right here. Okay? So that angle there that I've highlighted in blue has this little reference angle of pi over 6. Okay? So, in conclusion, the special angles in quadrant 2 have numerators that are 1 less than their denominators. In quadrant 3, the numerator is 1 more than the denominator. And in quadrant 4, the numerator is what? 1 less than twice the denominator. Okay? All right, folks. I hope that helps.